All right, I want to talk today about how to construct truth tables and how to use them to determine whether or not a proposition is contingently true, a tautology, or a self-contradiction. So let's start with this example, A or B and A. Now, when you're confronted with a compound proposition like this, the first thing you want to figure out is how many rows am I going to need in this truth table? And the way you figure that out is you count up how many elementary propositions are in the compound proposition. So the elementary or simple propositions are the propositions represented by each capital letter, A and B. I've got two simple elementary propositions in this compound proposition. A compound proposition takes these simple propositions and connects them with logical operators. In this case, the wedge, the or sign, and the conjunction sign, the and. All right, so that's what makes them up. So I've got two elementary propositions. So what you want to do is take the number of elementary propositions and square that number. So 2 times 2 equals 4. That tells me I'm going to need 4 rows in my truth table. 1, 2, 3, 4. The way you construct a truth table is, first of all, on the far left, you're going to have a column for each of the elementary propositions. So I got one for A and one for B. And then you've got the compound proposition here, and under that, you're going to have a column for each of the elementary propositions, one for A, one for B, another one for A, and a column for each of the logical operators, the wedge and the conjunction sign, because you're going to determine truth values for all that stuff. So here's how the blank truth table is going to be set up. Now let's fill it in. All right, here's how we do it. The way you fill in a truth table is you start on the far left, start with the first column of the elementary proposition, in our case A, and basically you divide the number of rows in half. So in my case, 4 divided by 2 is 2. The top half is going to be true, and the bottom half is going to be false. And then you go over to the next elementary proposition here, and you divide that number in half again. So in our case, it's just 2 divided in half is 1. And then you're going to alternate the true falses like that. True, false, true, false. Now, if we had 3 elementary propositions, if we had like a C in addition to the A and B, then we'd have 8 rows. And the first 4 under A would be true, and then it would be false. And then B, it would be 2 true, 2 false, 2 true, 2 false. And then C would be true, false, true, false. The reason you do this pattern is simply to make sure that in a systematic way, you've identified all the combinations of possible truth values for each of these elementary propositions. That's why you do that. Now, we've got A and B columns set up here. Well, guess what? We want to carry those values over to the columns underneath the compound proposition. So here's the A column. Again, it should be true, true, false, false. What am I doing? I'm just carrying the stuff from this first column under A and being consistent, saying, yeah, that's what A is here too. And the same over here with this other occurrence of A. True, true, false, false. And I'm going to do the same for B. True, false, true, false. Okay. I start always by filling in the elementary propositions, and then I work my way from that to the logical connectives. So I'm going to start here. The next one I want to do is the conjunction sign. Sorry, the column under the conjunction sign. Let me highlight that for you so we all know what we're talking about. I'm going to make it green. Now, why am I doing this one next? Well, I'll tell you why. Because I'm able to. I can't identify the truth value of the conjunction, the and sign, till I know the truth values of the 2 elementary propositions that it joins together. I can't do this column before I do B and A. But now that I've got B and A, Now I can do this. So here's the question I'm asking. The truth conditions for a conjunction sign are that both the conjuncts have to be true. In other words, this column gets a true mark only if both B is true and A is true. Otherwise, it's false. Okay, so ask yourself, in this space, is B true? Yes. Is A true? Yes. They're both true. So the and is true. Now, what about here in this next block? Well, A is true, but B is false. They're not both true. It's false that B and A. So false. B is true in this third row, but but A is false. So the conjunction is not true. False. They're not both true. And then neither one of them is true in row 4, so that's false. All right, great. So now I've got this conjunction sign. Now, and only now, am I in a position to determine the truth value of this wedge. Why? Because in order to figure out whether the wedge is true, I'm asking, is either A true or this whole stuff in parentheses? That's what this is asking. The parentheses join this together. It's like order of operations in math. And so I need to know the truth value of all the stuff in parentheses. And I only get that when I've got the truth value of the conjunction. The last thing that you identify the truth values of in any part of it is kind of the main operator for that part. So that this conjunction sign tells me the truth value of everything that's here in the parentheses. So when I'm determining whether this wedge, the truth values of the wedge column, what I'm comparing is the conjunction column with the A column. I'm going to highlight that green so that you know, oops, what it is I'm comparing. Now, the wedge is the last thing in this whole compound statement whose truth values I can determine. It's the main operator of the whole thing. If you want to know what's the truth values of the whole proposition, the column under the wedge sign is what gives it to you. And I'm going to highlight that yellow. Okay, so a conjunction is true if at least one of, this is a disjunct. The wedge is a disjunction. A disjunction is true if at least one of the disjuncts is true. Okay, so in column 1 here is at least one of, in row 1 rather, in row 1 is at least one of the disjuncts true? Well, yeah, A is true, so there you go. And the parentheses stuff is true. So we're good. What about row 2? Well, A is true, so we know it's true. Now, the parentheses stuff is false, so, but we got 1, that's all we need. What about row 3? Well, A is false, and the parentheses stuff is false. So the disjunction is false. We don't have at least one of them true. And the same goes in row 4. So this is the truth values of the entire compound proposition. Now, once you know the truth values of the entire compound proposition, you can determine whether or not this proposition is contingently true or a tautology or a self-contradiction. How do you determine that? Well, you ask yourself this question. Look at the main operator of the entire statement. Look at the truth values for the main operator. If they're all true, then it's a tautology. It's necessarily true. That statement can't possibly be false. If they're all false, then it's a self-contradiction. It can't possibly be true. We got a mix of trues and falses, like we have here, 2 trues and 2 falses, then it's a contingently true statement. Sometimes it's true and sometimes it's false, depending upon the truth values of the elementary propositions involved. So this entire compound proposition is contingently true. All right, let's do one more example, just for kicks. Let's do this one. Are or not S and not S. Okay, so first of all, again, we want to figure out how many rows am I going to need in this truth table. Well, we've got 2 elementary propositions. 2 squared is 4. So we're going to have 4 rows in the truth table. It's going to look like this. How many columns are we going to need? Well, we got 2 for the elementary propositions on the far left, and then in the underneath the compound proposition, 1 for each of the occurrences of the elementary propositions and 1 for each of the logical operators. Now I kind of fudged it here in this last one because I made a column not just for S and then a separate for the tilde, but just 1 column for not S. It's fine, don't worry about it. All right, next we want to fill in the truth table. How are we going to do it? Well, again, let's start on the far left with the truth values of the elementary propositions. The first half will be true, half will be false, and then we alternate them here, true, false, false. Let's carry over those same truth values for R to all the occurrences of R in the columns for under the compound proposition. So true, true, false, false. Under S, true, false, false. Okay. Now, the next thing I want to do is identify the truth values for not S. Now, how do I know what not S is going to be? Well, every time S is true, not S is going to be false. And every time S is false, not S is going to be true. That's just the meaning of negation. And once I've got this, now I'm in a position to determine the truth value of the conjunction. In what case is it true that both S and not S are true? And just when I say it out loud like that, I hope you can realize that there is no case where S and its opposite are both simultaneously true. These are all going to be false, right? Because whenever S is true, not S is false, and vice versa. False, false, false. Okay, now we are in a position to determine whether the negation of this entire stuff in parentheses is true. All right, now how am I going to determine this? Well, I take the main operator of the stuff that's inside the parentheses, the last thing I was able to determine inside the parentheses. Let me highlight that for you. I'll make it green. Okay, and now I go and say, when is all that stuff false? Well, in column 1, all this stuff is false, right? We got a false under this main operator. That means the negation of all of it is true. Same here. Well, actually, in all of them, we've got true straight down the line. Okay. And now, let me unhighlight this. Now I'm in a position to determine the truth values of the main operator of the entire compound proposition. So this is the main operator. And which columns am I going to be looking at here? Well, it's saying, when is either R or all this true? That means I'm going to be comparing this column and this column. When is at least one of the green columns true? Well, there, 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 and there, because this green column is always true. In other words, the negation of this contradiction is always true, and that means that this disjunction is always going to be true. All right, we filled out our truth table. Now we are in a position to figure out, is this compound statement contingently true, or is it a contradiction, or is it a tautology? And again, the way we do that is we look at the column under the main operator, and we see, is it all trues or all falses, or is it a mix? In this case, it's all true. That means this compound statement is a tautology. It's got to be true. always. And it has to be true because it's the negation of a contradiction, S and not S. Well, I hope that's at least somewhat helpful to you. Please shoot me emails if you got questions or don't understand some steps along the way.